lambda naught, what are you going to do? Okay, just grab a seat. I thought I'd catch you. Okay, so here, let's explain this again. The longer the wavelength, the lower or higher the frequency. The relationship between frequency and wavelength is inverse. Right? So a big wavelength is a small frequency. No, that sounds wrong. No. A big wavelength is a low frequency. A high wavelength, a big wavelength is a small frequency. Got it? Let's write it down. A big wavelength means a small or a low frequency. And a small wavelength means a big or high frequency. Now, what has more energy? A high frequency or a low frequency? Let's work it out with a thought experiment. If something is moving like that, it's a very lazy something. If something's moving like that, energy. And when doing that, its wavelengths are very small because the waves don't have long as they move away. If something's doing this, it's a lazy thing, low energy. And every time it does that, the wave moves away, and then it does the next one. It's got a long wavelength. Okay, so what is your correct response? If I give you a long wavelength, it's a small energy. If you a small wavelength, it's a big energy. So a big wavelength is this. There's the wavelength. A small wavelength is caused by something that vibrates very fast. This is caused by something that vibrates slowly. Right. Okay. Let's just try that again. Are you clear now what you must stand up for? Must you stand up for a big wavelength or a small wavelength? A small wavelength. Okay. Good. Fantastic. Now, do you guys know that you've just about covered the section with this? Frankly, that's about it. Now there's just problems. I give you a wavelength and you've got to figure out, or I give you a frequency and I give you a cutoff frequency, and then I say, will it be above or below the cutoff frequency? And then that's the answer. That's all. Would you like to try a problem like that? Should we try a problem? Okay, I think you need to just get a bit of a mathematical feel for this. So, okay, what do you, just give me, I'll give you a cutoff frequency. Okay. How would I abbreviate cutoff frequency? F? No. Let's give it a frequency of 7 times 10 to the 8 hertz. Happy with that? Don't let the big numbers scare you. That's the cutoff frequency for a certain solar panel or for photovoltaic cell. Now, you shine a light on it, a frequency equal to 4 times 10 to the 9 hertz. That's the frequency of light that shines on this panel. So my question to you is, will an electron be able to be knocked off? So what are you going to do? Who would like to tell me how you're going to tell? What's the question you're going to ask yourself? You're going to ask yourself what question? You're going to ask yourself, is the frequency of light above the cutoff frequency? That's the question you're going to ask yourself. Isn't that what you're going to ask yourself? And is that number above that or below that? Is that greater than that? I suppose you could type it into your calculator, that minus that, and see if you get a negative number. But looking at it, is 10 to the 9 greater than 10 to the 8? Yeah, it's bigger. So if you subtract that from that, you get that that is bigger than that. You'll get a positive answer. If you subtract that from that, you'll get a negative answer. But you've got to be able to look at it and say, which one's bigger? Okay, that's bigger. So what will happen? Will it knock an electron off? Will it? Will it? Will it? Will it? Okay, yes, it will. Great. That's the questions they ask in this exam. Was that too difficult?
No.
Now another way they're going to disguise this, so now you will say this frequency will knock an electron off. And if it knocks an electron off, how do we know it? A current flows, and a current will flow. And a current will flow. How do we know a current flows? Because our motor might turn, or an ammeter might show a current. Now do me a favor. Find out for me what that frequency would be in wavelength. What is that wavelength? Would you mind? Just find that wavelength. And just put a hand up, but don't give the answer when you're finished. I just want to see that you can work out a wavelength from a frequency. Got it, Matthew? Huh? Okay, what formula are we going to use? We're going to use C, or velocity, equals frequency times wavelength. We want wavelength as the subject of the formula, but it's always better practice to put in your numbers first. Okay, so we know C is 3 times 10 to the 8. 3 times 10 to the 8 equals 4 times 10 to the 9 times lambda. Right? So what do we do next? We divide both sides by 4 times 10 to the 9. That cancels out and leaves us with wavelength. So what is 3 times 10 to the 8 divided by 4 times 10 to the 9? 7,77 times. Sorry, I didn't hear that. I haven't. What is it? 0,007. 5. Is that correct? Everyone get that? 0,075. Great. Okay. What would wavelength be measured in? Meters. Now tell me, was that difficult? Was that difficult? No. Now suppose they gave you not this, but that. They said a light with wavelength 0.075 meters falls on a metal. The cutoff frequency of the metal is that. Will a current flow? Do you see you've got the same problem? What are you going to do? Convert that to frequency. And you're going to get the same frequency I've just rubbed off. Then you're going to see that frequency is higher than that, and then you can say, this will knock an electron off and a current will flow. And people were crying that that was too difficult. I say, that's lovely. Man, you can give me that for the whole exam. Give me 10 of those problems and I'll pass. Am I right with that? Okay. Let me give you another case, because I think, how many of you, when you see something like that, you just, maths? Do you get that feeling? Come on, I get it. When I see a problem like that, I go, it's like spiders. Then I say spiders. I'm bigger than a spider, I'll just step on it. So, okay. What if I said to you, L naught is, give me any old number.
5.
How much? No, a nice difficult number. I want to scare you.
50.
That's not scary.
Minus 0.
Let's get an ugly number. 1.37 times 10 to the minus 2. How's that? That looks more ugly. Okay, and I said to you, that's the cutoff wavelength, and I said to you, our light has a frequency of let's think of an ugly number. 4,9 times 10 to the 2 kilohertz. Oh. Do you guys know how to get kilohertz to hertz?
No.
Kilohertz to hertz. Are there more hertz? Are there more meters in a kilometer? Are there more meters in a kilometer than kilometers in a meter? Something like that. So I know my final answer is going to be bigger. Then kilo means 1,000. So then I'm going to say, to get it to hertz, I'm going to just say 4,9 times 10 to the 2 times 1,000. So that's going to turn it into kilohertz. Into hertz. So what am I doing? I'm saying kilo means thousands of hertz. But to turn it into ordinary hertz, I've got to multiply it by the 1,000. How would I convert a kilometer to meters? I multiply it by 1,000. How do I convert kilohertz to hertz? Multiply it by 1,000. Okay, so now we've got that. You see how they're throwing little steps in your way? But no, you're going boldly where no one dares to go. Now, the question is, will this frequency of light emit an electron or not? Will this frequency of light emit an electron or not? If that is the cutoff wavelength. If that is the cutoff wavelength. Okay, so how are you going to prove it? Now, can you work with frequencies and wavelengths at the same time? Haven't you got to convert one into the other? Haven't you got to get them both on the same? They've got to both be the same. What would you prefer to convert? This to wavelength or that to frequency? That to frequency. And then see which one is higher. Okay? Or if you converted this to wavelength and it was smaller wavelength, that means higher energy. You've got to know both, you could do either way. So let's go with it, convert that one into frequency. So this, what is the frequency of this particular, and what are we going to call it? F0. Because that is wavelength naught, therefore it would be F0. Just if you've got an answer, why don't you put up a hand, just so I can see if you know how to do this. Anyone got an answer? Fantastic. 3 people. Let's just get. So once you've got an answer, which one is bigger? Don't just say it, but just ask yourself which one is bigger, and that's now the end of your problem. So the formula is going to be C equals frequency times wavelength. So it's 3 times 10 to the 8 equals frequency times 1,37 times 10 to the minus 2. To get frequency, I divide both sides by 1,37 times 10 to the minus 2. That cancels out, therefore frequency is going to be that divided by that. And so what is my frequency? What is that divided by that?
2.2 times 10 to the power
2,2 times 10 to the power of 10. Is that correct? Now, is that bigger than that? Well, let's just get this into a nice, neat number. If we have that times 1,000, isn't it going to be equal 4,9 times 10 to the 5?
Yeah.
Okay. So which is bigger, that or that? The cutoff is higher than the given light frequency. Therefore, will the electron be knocked off? Will the electron be knocked off? Yeah. What's the answer? Come on, I want to see if you come. Who says no? Hands up. 1 hand, 2 hands, 3 hands, 4 hands. Who says yes? Well, what's the question? If this is bigger than the cutoff, the electron will be knocked off. But this is smaller, therefore no electron will be knocked off. Well done to the 4, 5 of you. That easy. Okay. Sweet. Now, I'm going to change tack. Seeing as there's so few of you, you know what? I think I'm going to give you all some work to do, and then I will tell you what else you're going to do. So have a look on page 314, and there's a test yourself on 314. And you can do that one. But one at a time, you are going to do this practical. Okay, now this is the practical for your marks. It'll be for this term or next, whichever we prefer. It makes no difference. Practicals are practical. Do you see what the circuit is? It's like all the circuits you make. It's got a voltmeter, an ammeter, a battery, and it's got 1, 2, 4 resistors. A resistor, a resistor, resistor, resistor. This is somewhat glued on. But I just want to show you. So it's like all the circuits you did before. Now to work it, I want to do this in front of the camera. To work it, you move this onto a particular resistor. Now this is how I switch it on. I put it there. You will see it gives a voltmeter reading. Where's something's fallen off there? Okay, this is with the switch open. So there should be a voltmeter reading, but I'm not seeing a voltmeter reading because something has fallen off here. There to there. So that's to the positive, that's to the negative. Why is my voltmeter not showing a reading? So that's to the negative. And that's to the positive. Our battery can't be flat. I did it yesterday and I... Oh, hang on, I've been off here. That must go to the positive. Okay, now we've got a reading, and if this is a 9-volt battery with no resistor selected, open circuit, you're going to get approximately 9 volts, no amps. You'll see our ammeter, no current. Here is the circuit for that particular circuit. So this is for your practical. It's a nice, easy practical. It's the circuit like you see